Hi, it's Jan Beta, and I recently got this Atari 1050 disk drive to repair, but I realized I don't have a suitable power supply for it, so I am going to build one today. And I am also going to make it a dual power supply that can power both an 8-bit Atari like the 800XL or the 65XE that I have, and one of these drives. So first step, set this aside. Because we can't do anything with it without a power supply. So yeah, as I said, we are going to build a dual power supply today. One of the voltages we need is 9 volts AC for the disk drive that we are just going to get from this 230 volts to 9 volts transformer. And then we need 5 volts DC for the computer, and that's where this Meanwell 5-volt power supply comes in. I'm going to link all the parts in the video description. The transformer actually wasn't that easy to find because it needs to be a rather beefy one, and yeah, I had to look around for quite a while to find one. So yeah, we also need a DIN plug for the computer, and we need a little barrel plug for the disk drive. I'm also going to use one of these rather nice Bahar enclosures that I first used for my C64 power supply build. Really like these, they're not that expensive. And I bought a bunch of them actually. This is a spontaneous idea that I had with the dual power supply because these cases, I had them lying around here and they are quite large, so we can fit both in here and have a nice convenient dual power supply in the end, hopefully. This build is going to be relatively straightforward considering the circuitry, but keep in mind that we're working with mains voltages and they can potentially harm or even kill you if you are not careful. So I don't recommend anyone taking my word as advice to build something like this yourself. I'm not a professional, as I've said repeatedly, and I may do stuff terribly wrong, so don't trust me on anything that has to do with anything. Basically, I'm a self-taught electronics person, and I'm doing this at my own risk. So do you if you are building something similar. Basically, we are going to add this IEC socket, which is a 3-prong standard mains voltage input socket that we're going to add on the backside. I'm also going to add the output cables on the backside because I want this mounted kind of under a shelf, so I can just turn it on and off from the front side and probably have the cables all come out on the backside to have it look nicer. I am going to add a little power switch with the light in it on the front panel. I don't think there's going to be anything else on the front panel really. The cables are all going to come out on the back, and the fuse I think is also going to be added on the back side. So that's what I'm going to do. Let's just figure out how we are going to build this. Ta-da! These walls are plastic, so you can drill into them easily. These are metal, the top part and the bottom part, so we're going to add a ground lug to those. So we have a properly grounded metal case. You always should ground your metal cases. I am going to add some insulation on the bottom part where I want to fix my transformer and my little 5-volt DC power supply. We're probably going to have this sitting like so. Or like so we have enough room for the connections. The DC power supply is a RS155 made by Meanwell, and I really like these little modules. These are industrial grade power supplies basically that you can build into your projects, and they have nice built-in places where you can add screws and things like that. I've used these a number of times and I really like them. They have screw posts here for all the electrical connections. The metal grill here is connected to the ground lug here, so it's grounded right away. Has a little dial to adjust the voltage in case you have a longer cable or things like that. And yeah, it's just a really neat little DC power supply that feeds on mains power directly. And it is compatible with AC mains from 100 to 240 volts. So you can use it in most countries in the world where you have mains outlets at all. So this is a really versatile little tool to have. And I actually had this spare in my parts bin. Bought a couple of these when I had the chance. So yeah, can recommend. This is of course a 5-volt power supply running at 3 amps maximum. So that's plenty for powering an Atari 8-bit. These of course should be wired in parallel. So we're going to have our mains power coming in. We have to have it on the front panel. After it goes through a fuse, the front panel is going to have the switch. And then we are going to wire these two, and the outputs from these are going to separate output wires. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They have excellent quality and very nice service, and they also have really quick delivery times and turnaround times. So if you need a circuit board you designed, produced quickly and cost effectively and in excellent quality, just take a look at the links in the video description. Back to the power supply build. This IEC socket goes here on the bottom of the backside, so the cable is sitting on the table most of the time. So are our two outputs, and this is for the fuse. The front panel is going to have an on-off switch. That's pretty much it. Yeah, my panels are coming along nicely. I'm just going to widen the output holes a tiny bit. Of course, we need to drill some holes into the metal part as well. Let's do that. I think I want to position these like so, something like this. And I'm going to screw this in through the pre-made holes here from the bottom, so I'm going to need 2 holes here. And I think what I want to do with this is to just use some cable ties through the holes here to hold it in like so. We can't really fit this in here with proper cables without risking this touching the metal case, so we don't want our 230 volts on there, so I'm going to use these holes in the other direction, I guess. It's a bit of a workaround, but I guess I'm going to get away with it. This is my private use thing, so yeah. Oh, and obviously we need a hole for our ground. Probably going to do that rather close to the edge here. Just going to add a little screw hole here and a little screw hole on the top side. This is just so that both sides of this split metal part are connected to ground. So we're going to run a little ground wire to the other side there. As usual, this is not perfectly planned. But what did you expect? It's me. So I'm also screwing down this IEC socket with some M3 screws. Yeah, that's not going anywhere. That's good. Our fuse solder is one like this that has like threads, and you can screw in and affix it on the case. And this is where our actual fuse, our glass fuse, goes in. Okay, our fuse holder is in place and our power inlet is in place. I think I also want to put some electrical tape or like gaffer's tape on the bottom side of the case, so just in case one of the cables gets ripped out or something like that, it doesn't short out with the case instantly. We are going to ground the whole case, so the fuse is going to blow pretty much instantly if one of the wires touches the case, but yeah. Yeah, but I'm still going to add some insulating layers here, so we're not going to run into any issues with that. And obviously I'm going to use the fancy pink stuff. Because, yeah, just in case I ever look into this again, I just want to be happy. Perfect. Yeah, and as for the transformer, this is of course not the ideal way to affix it using cable ties, but I could make some brackets and properly screw it to the case, but I'm probably not going to bother with that. I just think I'm just going to use cable ties because this is pretty much going to be stationary for me, and I'm probably going to use some glue with the transformer as well. Yeah, that's what I'm going to do. So my cable tie plan seems to work. I'm just going to put some glue under this. I think I'm going to use some epoxy to epoxy it in place. Okay, so that's a very Jan Beta way of doing it, but I guess it's going to be fine. It's already pretty sturdy here. I am going to get away with it. I'm not recommending this at all. So, wiring this. We are going to have 3 wires from the mains coming in here. There's a ground wire. That's this middle one. We have a neutral and we have a live wire. We are going to feed the live wire through the fuse, out of the fuse, into the switchable contacts on this. And then we are going to connect this and this in parallel. That means we have 2 connections coming from here to here and here. And we are going to wire the neutral directly to this switch, this golden switch contact, which is the contact for one of the sides of the light in here. That's a light that's powered by mains power, so we have our mains power in here. And then we are going to go out of this into here and into here. And then we have both our power supply sections wired with live and neutral. We are going to wire up the ground connection from here to our case ground, and we are also going to wire it up to our ground on our power supply here, our 5-volt DC power supply. And then we have our output 9 volts AC on these terminals here, and we have our 5 volts on these terminals here, I think, yes. And then we are feeding wires out of the case, and we are going to connect the connectors we need for the things we want to power. And I'm going to use mostly crimp contacts like these that we can crimp wires on with a tool like this. I think these are pretty handy for building power supplies. I've done that a couple of times now and it worked well. Let's do that and start here. And I'm also going to use heat shrink tubing over the connections that have mains voltage on them, so don't accidentally get shocked. I'm using these fork-shaped ones to connect to these screw posts here because they work pretty well. And I'm using round ring connectors for connecting the case. I'm going to use these round things to connect the case with some screws. Okay, I think that might be all the wiring for the power input. And I deliberately didn't put any heat shrink on the earth ground connection here. Let's double check. So mains comes in here. This is the live that goes through the fuse, through the switch, and from the switch to our power supply section, basically. The neutral is connected on the light in the switch, and it is connected to here, and it is going to be connected to our other DC power supply. Earth ground is connected to the case through these little things and to our DC power supply. Yeah, and then we should be able to get our voltages from the output on the transformer, the AC, and our DC from the little DC power supply. And for the ground connections on the case, to make a better connection, I'm going to use some of these teethed washers to grip into the metal. So next up, I'm going to make the connections to the DC portion of this. So that's our 3 connections made to our DC power supply. The AC is also connected. Our ground is also connected to the bottom case that we have installed. We just have to connect the output. And for that, I think I want to use some just regular speaker cable that I have lying around, because that's suitable, I guess. We just need 2 wire connections for the DC and the AC. So we're going to use that. And they don't have to be particularly long for my use case, because this is going to be, as I said, this is going to be pretty much a stationary power supply that I'm building to my needs. And we don't need hilariously long cables for this. Yeah, this is just some ultra cheap, it's like standard copper wire 1 millimeter, I guess, or 1.5 millimeter, I think is what it's sold as. I think it's not quite 1.5 millimeter diameter. This is very cheap speaker wire, so for your loudspeakers. And I'm just going to use this leftover stuff for my electrical connections, which isn't a problem because this has a large enough diameter. And yeah, we're going to get away with it. So I guess it is time to test my construction so far. See if we get the output voltages we want on the outputs we want them. We are going to connect this to the mains. This is an FI switch, like ground fault interrupter, which in case anything goes wrong, this is going to protect me from dying, most likely. What this does is it detects if however small current goes to ground, this is going to blow this switchable fuse. So this is basically a fuse that prevents me from getting shocked for very long. This is a very fast acting fuse, so if I touch anything that's live, I am going to become the ground connection, and this is going to blow and switch off the power really quickly. Yeah, this won't work because I didn't put a fuse in. We have to find a little fuse. So according to my calculations, this should not draw too much on the mains side, too much current. I am going to put a 0.5 amp fuse, slow blow fuse in here for now. Now this should be energized. As you can see, we wired something up the wrong way. The light is permanently on. We permanently connected the wrong pin, I guess. Yeah, we connected the wrong one. Okay, so the middle pin goes through the light if it's switched on. If you want the switch permanently lit, you have to connect the permanent live wire, yeah, on the other pin. So now this is how this is supposed to be. We have this switched off, as you can see, 0, 1, it's switched on. Okay, so you have to take into account which wire is connected where. You can measure that, of course, with the multimeter before installing, if you aren't as naive as I am. And now for the somewhat important question, if this thing actually outputs the voltages we need. So we are going to measure the AC. This is going to be higher. Yeah, this is like 11 volts. 10 volts, thereabouts. Yeah, this is always a bit higher with these just a transformer if you don't connect a load. And then we should have 5 volts DC here. Yep, the power supply works. The pin out for the Atari computer is a 7-pin DIN. This is the side watched at the computer, so it's the solder side of the plug we are going to solder on there. And as you can see, we have 5 volts on this pin 6, pin 1, pin 4, half basically, and the other half is pin 5, pin 3 and pin 7. Those are ground. I don't know why it says 0 volts. It's ground basically. And pin 2 is for a shield, but that's not even present in the power supply that this came with. So we are not going to connect that probably because we are using an unshielded cable anyway. And the AC side is going to be a barrel plug, a standard size barrel plug that I'm going to use. And to get it through these holes without risking damaging the cable, I'm using these handy little rubber grommets. These have like a groove here, so you can put them in these holes and put the cables through them so they don't get hurt by the case. And as for the strain relief, I think I just want to put a little knot into the cable on the inside here. So let's see, how much room do we need? Not that much. That's a pretty crude way of doing it, obviously, but yeah, it's going to do. Yeah, for the AC wires, the polarity obviously doesn't matter because it's AC. Okay, I got my 7-pin DIN connector and I got my cable, and I'm going to connect these with solder, basically, the pins. So I'm making huge blobs on each side here. So yeah, it does look super messy, but as you can see, I just connected 3 pins each side, and we have to connect this side to the positive and this side to the negative. Yeah, there we go. That should be it. And I'm going to use some electrical tape to prevent these two from shorting out against each other. So that should do. Yeah, this is going to do nicely. And for the AC or disk drive side of things, I'm going to use one of these, which is a barrel plug that came with a power supply. You usually get a number of these with, if you buy a universal power supply, you usually get a number of these and you can fit them in a little connector. So you have the connector you need for the device you want to power with the power supply. I always keep these, and they are pretty easy to work with. You can just solder to these pins. In this case, it doesn't even matter which pin we solder to which wire. And you can just put some heat shrink tubing on there and have it be a nice sturdy connector. And yeah, I usually do this and try which one fits the device I want to power. So this should be +5, yes. That's how it goes into the... Yeah, okay, this is positive on this side, the correct side, and this should just be AC. So we're setting this to AC. We should have our AC voltage on here, yes. That's looking good. Should be able to power an Atari and an Atari disk drive with this now. And of course, this power supply basically could also be used to power a Commodore 64 because that requires 9 volts AC and 5 volts DC. So you could just hook up the correct DIN connector for a Commodore 64 and use this as a Commodore 64 power supply. And here's some glamour shots. It's not that glamorous, but at least the color scheme matches the early Ataris a bit. I mean, this is white, the Ataris are beige, but yeah. And as I said, I don't need massively long cables because it's just going to be sitting right next to the machine, basically. That's why I left them so short. Yeah, that's the build. Let's try if it actually works. Okay, so I hooked up the other Atari 1050 disk drive that Darren sent me. That allegedly works, but needs a new belt or new belts. And my Atari 800 XL that I had before. Let's see if everything works according to plan. So this powers on. Yep. And the disk drive also powers on. That's rather nice. Okay. So yeah, we have power. Seems to work. Yeah, unfortunately, I get a boot error if I turn the Atari on with the Option key pushed down. That should boot the disk right away without BASIC involved. But as you can see, my disk or the disk drive is broken, but it's powered correctly. So it uses the power supply to work and powers the computer and the disk drive, which is what I wanted. So yeah, the power supply works. My disk drive doesn't. But I wanted to fix the disk drive in the other video anyway. So yeah, power supply works, disk drive doesn't. Next video, disk drive repairs, I guess. Yeah, I guess that's it for this video. I'm going to attempt to fix some Atari 1050 disk drives in the next video, or one of the next videos. Not quite sure how my scheduling is going to work. Thank you very much for watching. Thank you for supporting me on Patreon or on the channel memberships page or through some other donations. Hope to see you all again on this channel pretty soon. I'm in Beta. Thanks for watching. See you next time.